Hey guys, in this video I want to talk about a little about mobile optimizations and how you can achieve a better quality game and a better optimized and well looking game. So first of all, what you need to know is the difference between ES2 and ES3. So what I'm using right now is the Unreal Engine 4.27. If you wanna target most of I mean 100% of the mobile devices out there, specifically Android devices out there, you need to use something like UE 4.24, UE 4.23, or even older versions, because uh, there are like a lot of devices out there which they're not supporting ES 3.1, which UE4 is using, and UE4 is not supporting ES2 anymore. So this is something that you should keep in mind. So first of all, let's go to the project settings, go to the edit, project settings, and go to the target hardware. And so first of all, there are two options for you. One is Vulkan. Vulkan is really good. It is well optimized. It is good looking. It is really great. And the other option is just using the simple ES 3.1. When you're using Vulkan, let me just show you how to just activate the Vulkan. So when you go to the Android, I hope that I'm not wrong. Yeah, it was somewhere around here. Yeah, here it is. So just check the support Vulkan and detect Vulkan device support. And what this does is that Vulkan is another renderer. Uh, so you have two options. If the target device is supporting Vulkan, the game itself will be using the Vulkan renderer to render all the scene for the game. If the device isn't using it, it will simply revert to the ES 3.1. And if you are using an older version, you will have another option called OpenGL ES2. So you can check that out as well, but I'm not having any option here. So after enabling Volco support, just go to the target hardware, and you need to, I haven't seen any difference in performance between these two, but maximum quality is better in quality wise, definitely. You have bloom, you have some effects that are really good. Anyways, the next thing that we're gonna change is go to the in the project settings, go to the rendering. You should have this disabled, enabled, because it will disable the vertex fogging in mobile shaders. And if you are using CSM cascades, you will need to have it to set to 1, unless there's a really big difference in how the game will look. In that case, you will need to achieve the performance that you target from another way. So, but I didn't see any difference, so I'll set it to 1. Mobile MSAA is really good to achieve a higher quality in your game, so I'd suggest use something like 2 or 4, which is really great. You can use no MSAA as well, doesn't really matter. Don't ever use these two planar reflections, which mobile PPR is really new, and mobile ambient occlusion, which aren't supported on most of the devices out there. Um, One thing that is really important in here is occlusion culling. So what it does really is that, let me show you. When the camera is here, you can't see this wall behind this. When you're playing the game, you can't see that wall. So what that does, let me see. So what this occlusion calling does, it makes sure that this wall here isn't rendered on the scene. So it will be like, I don't know how much that counts. Let's see. So it will be 12 triangles less to draw to the screen. And that's a really good thing. And when you see it, it will again call it back to the screen. So this is something that will lower the load on GPU, but it will make the load higher on CPU wise. So, oh, where was it? So what you will be looking here is that if you're CPU bound, you will actually need to have all the load on GPU, which in that case you have to uncheck this one out. But if you are not CPU bound, I'd suggest you to have this checked out because it will help you to get a real better performance. But keep that in mind that if your target devices are uh, limited in CPU performance, this option will hit the performance, and sometimes the hit will be so clear to see. Other than that, we have texture streaming. I really didn't try to have it checked. I always uncheck it, but I don't really know whether it makes a difference or not. But this is completely the same as occlusion calling. It just calls the textures that aren't on the screen, that aren't visible to you. You have the reflection capture. Sometimes I mean, most of the times it's not that important. 128 is, I mean, lower than what I expect, so I wouldn't really lower this amount. After that, what I wanted to show you is mobile HDR is, I mean, when you're using ES 3.1, you will always have mobile HDR checked because you have the option to use Vulkan, right? And Vulkan is completely dependent on mobile HDR. So nothing to really speak about here. Um, you have the option to uncheck all of this mobile shader permutation reduction. So what I would suggest you is that if you don't have any foliage on your screen like this scene here, if you don't have any foliage, just go on with a complete static lighting. If you want to have shadows as well, then you would have to check this one out, support movable directional lights. But otherwise I would suggest uncheck this and make this one 0. And if you're not sensitive to shadows, or simply if your game is running in a first person, it's like a first person shooter, then you will have the option to uncheck this one as well. And if you're not using cascade shadows or any kind of cascade shadows, you have the option to uncheck this one as well. um Other than that, so after changing all this stuff on all the settings in the project settings, it's uh now we have to go, there are a lot of factors that are really important in when it comes to building a mobile game. One is materials and one is the meshes, so the meshes should not be complex at all. I would say in a scene you shouldn't be rendering more than 500k polygons. It's not like you have the ability to render 2 millions, 5 millions, 10 millions. No, it's not like that. It's always less than a million, and at the worst case scenario, it's like 6 or 7 or 800, not more. So you have the option to preview it's like a simulator of what you will be seeing on the mobile devices. So you just go to the settings, preview rendering level, and you have the option to either use ES 3.1 or Vulkan. I would say go forward with Vulkan. It will take some time. I guess after that it will compose some shaders. Yeah. So I'm just gonna pause the video for this one. Well, after you've changed it, it will be there will be a lot of shaders to be compiled. Then you will have to rest a little bit, maybe go drink a coffee or something. Anyways, so what I wanted to show you, while you're in Vulkan mode, you have the option to go here, and this one is optimization view modes, shader complexities for materials. Most of the times, the materials that are really complicated to process are the transparent materials and reflective materials. So in this case, the only transparent material, it's not actually a transparent material. It's, the only thing that we have here is this one. So let's go in it. So it is a masked material. In most, I mean, masked materials and transparent materials are completely different than others, and you will use each one that you will need to. Um, but in both cases, I would suggest you to, in the shading model, use the unlit because it will be really cheap to process. Let me just show you real quick. So you saw it. I mean, this will be the drawback, definitely. This is unlit. It can't show the reflections, it can't show the light, it can't show pretty much nothing. You have the option to use the emissive color as well if you want to. So if you go to the optimization model, shader complexity, it is now pretty much all green. It was like around here, and now it's nearly as perfect. So this is one thing to keep in mind if you go to the sorry content, which we don't have anything here. Let's just go to the glass, because most of the times what material that you will have problem with is glass. So let me show you how the glass will react to different surfaces. So this is how the grass will look like in shader complexity, and if we just unlit it and use emissive instead of base color, it will be all green. I mean, there won't be any kind of reflection or any specular, just nothing. It's just a glass, a very simple glass. But you will have the performance at your end, and that's what we're talking about right now, right? So this is one thing to keep in mind. The other thing is about the meshes. Let's go check this one out. Not this one, this is real. So when you open up a mesh here, you have the option to change the LODs. Actually, in this case, we have to build LODs for it. These triangles, in my opinion, for characters, they shouldn't be more than 70k, 70,000. They shouldn't be more than that. That's like the maximum number that you can use. For a mesh, it actually depends on the size of the mesh, but I would say that let's try to keep it less than 10,000. This is pretty good. This is, I mean, insanely optimized. So anyways, just imagine if it was like 120,000, then what should we do? Um, just go to the details panel, and under LOD settings, we have the option to auto compute. Most of the times it just doesn't work, so let's just get rid of it. And then in number of LODs, I normally use 8 to see what happens. and this happens. So let's just try to see which was perfect for us. Okay, so in this case, what I would do most of the times, let's show it to you on another prop, something like, I would say this one's good. Oh yeah, definitely. This one needs some optimization for sure. So this is 11,000. I would say that this one needs to be like 2 or 3,000. So just check this one, go to 8, apply changes. Let's wait a little bit. So what I'm gonna do, what I always do, is just go to the LOD 0, and in the screen size, a screen size is the number you see here. This is the current screen size. I mean, the number changes. It practically shows you what the screen size means in here. So I would say, when you're at LOD 0, the screen size means that uh, when it should transfer from LOD 0 to the upper LOD, which in this case we don't have any upper LOD, so it will be like the highest value we have here. So in all the cases, I would just set this one to 100. So because this is so unrealistic, we don't have any number like 100. It's like 2, 3, 4. No, we can't achieve 100, and yeah, you get what I say. So this is our highest number. So LOD, after LOD 0 is the LOD 1, and there's literally no changes. And in mobile, this is the highest quality possible. So most of the times we don't need this one either. Um, so when we're at LOD 1, this means that when we will be transitioning from LOD 1 to LOD 0, so if you, for example, set this one to 0.8, it will be LOD 1 here, and it will be LOD 0 here. But we don't want any of them, so just 100 for them both. LOD2. LOD2 is pretty good for me. It's high quality for a mobile game, so we'll stick to LOD2. For sticking to LOD2, I told you that I don't want LOD1 as well, so to tell it to the engine, we will go to the LOD2 and set this one 100. I told you that I want to use LOD2, so let's go to LOD3, and then I would say that I want LOD2 from somewhere like here, so maybe 0.1. And then keep in mind that changing this stuff requires CPU power. So, and drawing all these cells requires GPU power. So any transition requires CPU, and any processing, any actually rendering requires GPU power. Um, what we're going to do right now is that I don't want all these assets to come to the screen one by one, because that will require some CPU power. What I will do is I will use, as I told you, I will use LOD2 from here. So I will go to LOD2 and set it to 1.1, and then I will set them all 0.1 to the point that I would say that okay, that's enough. So I'm not going to use LOD 7 because that's too much. So it will be like this. So it will just transition once. Just look at the LOD here. We only have one transition, which needs some CPU power. I just wanted to show you, and now look what happens. We can simply fix this stuff by going to, yeah, and it is fixed now. Okay, so most of the times the characters are really complicated. This one is really optimized, but I would suggest you to go with some kind of LODs as well. So let's make 4 LODs. And okay, if you want your game to be pretty optimized, this is what I would suggest you to go with. Otherwise, this is pretty good too. So the next thing that I wanted to show you is because it's all about the load on CPU and GPU, and most of the times CPUs are really weak to handle their job. GPUs are really surprisingly well at what they do, but unfortunately we're not uh, in that time where CPUs are powerful. So what we have to do most of the times is that just lower the load on CPU and transfer the load on GPU. So there are a lot of meshes on the screen. Actually, not now. This scene is pretty um, light, I would say. So how would you see that? So just go to the brush wireframe, and this is all the assets that are being drawn to this scene. I would say that this is pretty good. So uh, what you will have to do most of the times is that just try to make a scene something like this. Um, the last thing that I wanted to talk about is merging actors. So we have a lot of actors here, which all of them are just separated. What merging means is that we have all these actors here, right? And these are drawing to the, I mean, transferring from the CPU to the GPU while when you are using calling. You have this scene in front of you, and when you rotate your camera and try to see this angle, the CPU will try to transfer all the assets to the GPU, so then GPU could process it all. What merging does is that it will, instead of transferring 1, 2, 3, 4, 5 meshes, the CPU will only handle one mesh at a time, and it will be drastically faster. So you will gain a lot of frame rates with doing so. So how I would always do merging is that just I will try to start with one mesh at a time, and I will always try to choose the meshes that are close to each other. So I'll start with this one, and I'll just right click on the location, copy its location, and then I'll hold control and then select the other meshes, and then right click, merge actors, doesn't really matter, save, and then I'll delete this, and I will drag this one to the scene and right click, paste. And this is really it. After that, if you are using this static lighting, you will have to build a lighting for yourself to see what happened, and keep in mind that after merging all the actors, the polygon numbers will get really high, get drastically higher. So after that, you will have to go forward and try to change LODs a little bit, as I told you. Um, After that, there are, I mean, if these don't work for you, the problem that you're facing is most probably because of the code you've written. There are some scripts for that as well. Stat game, for example. So there is a tick time, world tick time, and you can have it. Let me just show you again. Stat game. Yeah, this is a script where you can use it while you are playing your game. You can just hit the console command, hit the console button, and write stat game, and then see what's happening inside your game under the hood. Maybe that's the problem, because also I mean, all the codes are pretty much processed by the CPU, and as I told you, CPUs are not that strong. So maybe this is another problem you're facing. Stats game, okay, and the other one is stat GPU, and this will help you to see more details about what's happening. I mean, there Epic Games has already explained a lot about this stuff, so I'm not going through about this stuff, which it will help the video to get really longer, which is already long enough. So I guess this is it. I don't have anything else to add here. If I found anything else, I'll add it to the video, maybe a part 2 video. But anyways, this is it. If it helps you, please hit that like button, and if you have any questions, please comment it down below. And if you've enjoyed, if you're enjoying all the videos I post here, you could just subscribe for more videos. Thank you guys.